All right, this problem is asking us where is speed increasing and decreasing? And we're not given any function, we're just given a graph of a function. And the function is position of time, and we've got this graph. Okay, again, the basic concept of speed increasing and decreasing. It's a little tricky because velocity is a vector measurement. If I'm going 50 miles an hour this way, it's positive. If I'm going 50 miles an hour this way, it's negative. Okay, so it's not a simple matter of asking is velocity increasing for speed increasing. I mean, 50, 60, 70 going to the right, that's pretty easy to figure out. But when it's negative 50, negative 60, negative 70, it gets a little bit weird because these are all negative numbers and getting more negative. So I can't just ask is velocity increasing. Okay, I have to do a little more analysis. And what we do is we have to look at velocity and acceleration. So let me just again show you a quick demonstration. Internalize this, and this whole process becomes much easier. So if I'm going to the right, all velocities are positive. I'm going to the left, velocities are negative. That's just based on the XY graph, axes. If I'm going up, it's positive. Going down, it's negative. Okay, let's just talk about going left and right. So if I'm going 50, 60, 70 to the right, all that is positive. Okay, velocity is positive. Okay, now 50 to 60, that's 10 miles an hour more positive, so that's plus, and 60 to 70 is plus 10. So velocity is positive and acceleration, they're both positive. The same sign, speed is increasing. Okay, now let's look going to the left. If I'm going 50, 60, 70 to the left, well, those are all negative velocities, right? Now, the acceleration from negative 50 to negative 60, that's more negative. So that's actually a negative acceleration. 60, negative 60 to negative 70, again, that's more negative. That's negative acceleration. So I've got negative velocity and negative acceleration. Again, the same sign, speed is increased. So when the signs are the same, both positive or both negative, speed is increasing. Now, take the example going 70, 60, 50 to the right. Those again, all positive, so velocity is positive, but look at the acceleration. From 70 to 60 is 10 miles an hour less positive, so that's a negative. 60 to 50, that's a negative. So acceleration is negative, velocity is positive. Those are different signs. Speed is decreasing. Okay. If I take a look at that now going to the left, 70, 60, 50, because it's going to the left, those are all negative velocities. Velocity is negative, okay? But from 70 to 60, that's negative 70 to negative 60, that's less negative, so that's actually positive. Negative 60 to negative 50, that's less negative, that's a positive. So I've got negative velocity, but positive acceleration. Again, different signs, the speed is decreasing. Okay. Okay, so that's what we got to do. We've got to analyze speed. We analyze speed by looking at velocity and acceleration. And I figure out where the signs are the same, where the signs are different. Okay. So what do? I have a graph here of position. How do I get velocity out of position? Well, let's take a look. Let's think about this. Um, this is x of t, and that's position. Velocity at time t is equal to the derivative of position. Oops. Okay. And that's basically the slope. Okay. That's the slope of this graph. Acceleration at time t, that's equal to the derivative of velocity at time t. Well, the derivative of velocity is the second derivative of position, okay? Now, derivative of this function, this graph you're looking at, is the slope. The second derivative is concavity, okay? So if I want to analyze the velocity, I check to see whether the graph is sloping up, sloping down, positive or negative slope. Increasing velocity, decreasing velocity. If I want to look at acceleration, I look at the second derivative of position, which is concavity. Concave down, acceleration is negative. Velocity is decreasing. And you can see here, it's very positive, a little bit less positive, 0, slightly negative, slightly negative. Okay, so that's what we're going to do. Now, I want to find speed increasing. Oops. So speed increasing. I want to look for intervals where velocity is positive and acceleration is positive, or I want to look for velocity negative and acceleration negative. Okay, So again, velocity I'm looking for sloping up, and acceleration positive looking for concave up. So let's take a look. So here's slope going up, so that's positive velocity, but it's concave down, so that doesn't work. It's got to be both. Here's slope up and concave up. So yeah, this is an area where I have speed increasing. So this is from 4 to 6. The endpoint here is 6. Okay. Right. So from 4 to 6, velocity is positive, acceleration is positive, speed is increasing. Okay. What about velocity negative and acceleration negative? So again, like this is slope up and concave up. Okay. So what about velocity negative, acceleration negative? So that's going to be slope down, right? And it's going to be concave down. Okay, so I have slope down where? I've got slope down basically right here, okay? And for part of that, it's concave down. For part of it, it's concave up. So I need to have it concave down, all right? So, and this POI, this point of inflection, where it changes from concave down to concave up, is at t equals 3. So it's just from 2 to 3. So this is 2 comma 3. Okay, now for speed decreasing, that's going to be different signs. So velocity positive, acceleration negative, or velocity negative, acceleration positive. Okay, so velocity positive, that's slope up, right? And acceleration negative, that's concave down. Okay, so where do I have? Well, I have a slope up and concave down. So here's slope up, and this is concave down. So I guess it would be from 0 to 2. All right, that makes sense. That's 0, oops, 0 to 2. And where do I have velocity negative and acceleration positive? So velocity negative is slope down and concave up. Okay, so slope down and concave up is going to be, well, this is all slope down. One place is slope down. This is concave down. This is concave up. So slope down and concave up is from 3 to 4. That's it. That's what you've got to do. Just one slow step at a time. You've got to understand you want either same sign or different sign. You've got to take a moment and realize that if you're looking at a graph of position, velocity is the slope. And on that same graph of position, acceleration is a concavity. And then you simply go through the steps one small step at a time.